All right, today we're going to decode the secret language that makes AI feel, well, kind of like magic. It's the reason your apps seem to read your mind, and it's all thanks to something called a vector database. So let's break it down.
You know that feeling, right? You search for something and the results are just so good, it's almost spooky? Or your music app tees up a new band and you instantly love them. It really feels like these systems just get you. But of course, it's not magic, is it? It's actually a brilliant piece of engineering. A totally new way of organizing information so that computers can understand what things mean, not just what words are typed. They get the context.
Now, to really get why this is such a big deal, we have to look back at the old way of doing things. Let's talk about the limits of just a classic keyword search.
I mean, think about this simple problem. If you search for the word dog, a basic search engine is just going to look for the letters DOG. But what if the best article for you uses words like canine or puppy or retriever? The old system? It would miss it completely.
So on the one hand, you have that traditional keyword search. It's super literal, just a simple word match. But on the other hand, you have what we're really after, semantic search. We want the computer to search for the idea of a dog, not just the three-letter word.
So how in the world do you teach a computer the idea of a dog? Well, this is where it gets really, really cool. We basically had to teach AI a brand new language, the language of meaning itself. And the key to this whole thing is a concept called an embedding. Basically, it's a way to turn anything, a word, a sentence, even a picture or a sound, into a long list of numbers. We call that list a vector. The best way to think about it, it's like a set of GPS coordinates, but instead of mapping a physical place, it maps a concept's location in this giant invisible space of meaning. So how does that happen? Well, at a high level, you feed something, like a sentence, into a huge AI model. That model looks at all the context, all the relationships between the words, and it translates that into one of these numerical vectors, the embedding. Each of those numbers represents some kind of abstract quality, some of which we might not even have a name for. And here's the absolute breakthrough. We're not just storing raw data anymore. We're storing data that actually understands its own context. This is exactly why the vector for puppy and the vector for dog will have very similar numerical coordinates. The computer now knows mathematically that they mean similar things. Okay, so problem solved, right? Well, not quite. In solving the meaning problem, we've created a fascinating new one. We now have this amazing way to represent meaning, but how on earth do you search through all of it?
Yeah, searching these embeddings is a massive challenge. First off, these aren't simple X and Y coordinates. We're talking about vectors with hundreds, sometimes thousands of dimensions. And you're not looking for an exact match. You're looking for the closest neighbors in that space. And finally, the sheer scale of it all is just mind-boggling.
We are talking about systems that need to search through billions of these super complex, multidimensional points in the blink of an eye. A standard database would just fall over. It was never, ever built for this kind of problem.
And this is where our hero finally enters the scene. We needed a totally new kind of database, one built from the ground up to handle this one very unique challenge.
Enter the vector database. Its entire job is to do one thing, and do it incredibly well. Take a query vector and, almost instantly, find the most similar vectors in its enormous collection. It is the specialized tool built for the age of AI. Now, this is where the real magic happens. It's not just about finding similar things, it's about understanding relationships. Let's look at the most famous example. Here are some simplified vectors for the concepts king, man, and woman. You can see that king and man have some similar numbers, right? That is not an accident. Because these vectors represent actual concepts, you could do math with them. It's called vector arithmetic. So what do you think happens if we take the vector for king, subtract the vector for man, and then add the vector for woman? You get a brand new vector that is incredibly close to the actual vector for queen. I mean, how amazing is that? It proves the AI isn't just matching words, it's understanding these abstract relationships like royalty and gender through pure mathematics. Okay, so this is obviously incredible technology. But so what? Why should you actually care about any of this? Well, because you are already using it every single day, often without even knowing it. Yeah, this isn't some science fiction, far-off tech.
Vector databases are the engine running underneath so many of the biggest parts of the modern internet. From the recommendation engines that pick your movies to the AI chatbots we all talk to. This is the invisible architecture of the new AI-powered web.
So the next time your music app finds that perfect new song, that's a vector database, finding a song vector that's close to the ones you already like. When you search for work pants and get back professional trousers, that's semantic search powered by vectors. This tech is absolutely everywhere, quietly making our digital world feel smarter and more intuitive. When you step back, what we've really done is we've started teaching computers to understand the nuance and context of our world in a human-like way. It's a fundamental shift, and it really leaves us with a huge question. If we can truly create a mathematical map for all of human meaning, where is that map going to take us next?